Chapter 4, Problem 34.
An automobile whose speed is increasing at a rate of 0.600 meters per second squared travels along a circular road of radius 20.0 meters. When the instantaneous speed of the automobile is 4.00 meters per second, find A, the tangential acceleration component, B, the centripetal acceleration component, and C, the magnitude and direction of the total acceleration.
Our given values are the automobile's acceleration, or increasing speed, which is 0.600 meters per second squared, the radius of the curve it is driving upon, which is 20.0 meters, and the instantaneous speed at which we must calculate our values, which is 4.00 meters per second. The formulas we will use are for centripetal acceleration, which is v squared over r, acceleration total, which is the square root of the automobile's acceleration squared, plus the centripetal acceleration squared. And to find direction, theta equal to inverse tangent times the centripetal acceleration over the tangential acceleration. Step 1 for A is to find the tangential acceleration. Here is a diagram to try to help explain what is being found. AT is acceleration tangential, and AR is acceleration centripetal. R, the radius, is equal to 20.0 meters. Increasing speed, as it is stated in the problem, is also known as tangential acceleration. So the answer is simply the given value of 0.600 meters per second squared. To solve part B, step 1 is to find centripetal acceleration. The formula is v squared over r, where v is instantaneous velocity and r is the radius of the curve. Plugging in the values brings us to 4.00 meters per second squared over 20.0 meters. Simplifying this gives us 16.0 meters squared over 20.0 meters times seconds squared. Solving this brings us to 0.800 meters per second squared as the centripetal acceleration. To solve part C, step 1 is to find the total acceleration. The formula for total acceleration is the square root of the automobile's acceleration squared plus the centripetal acceleration squared. Plugging in these values gives us the square root of 0.600 meters per second squared plus 0.800 meters per second squared. Simplifying this brings us to 0.36 meters squared per second to the fourth plus 0.64 meters squared over seconds to the fourth. Adding them together gives us 1.00 meters squared per second to the fourth. And finally, square rooting that, so the acceleration total is 1.00 meters per second squared. Step 2 of part C is to find the angle of direction, theta, of the acceleration. This can be found using the formula theta equals inverse tangent times the centripetal acceleration over tangential acceleration. Plugging in the values found in parts A and B give us inverse tan times 0.800 meters per second squared over 0.600 meters per second squared. Solving for that gives us theta equals inverse tan times 1.333 which brings us to our answer 53.1 degrees inward from the path.